Welcome to my demo session for attribute stream-based access control with the streaming attribute policy language. My name is Dominik Hortelbeck from the Research Institute for Telecommunication Corporation in Dortmund, Germany. In this presentation, I will demonstrate the streaming attribute policy language and engine. The engine and documentation are available at sapl.io. The engine is open source and is licensed under the Apache license version 2.0. The engine comes with a full implementation of the policy language, an embedded policy decision point for Java, code editors, testing frameworks, libraries for geofencing, and different PDP server implementations, both with and without UIs, a playground for testing and learning how to use the engine, and framework integrations for Java and Spring Boot, as well as Python and Django. On GitHub, a number of demo projects are available, and everything you will see in this presentation is freely available on GitHub. First, let me briefly introduce the motivations for creating a new policy language in the domain of attribute-based access control. The foremost motivation for creating this language and engine are data streams and session-based applications. For example, collaboration tools or real-time geofencing. Also, event-driven architectures are gaining increasing importance in practice. XACML also poses some limitations in its expressiveness. For example, in XACML you cannot parameterize the access to external policy information points. In addition, SAPL attempts to improve upon the usability of attribute-based access control policy languages. The architecture of an SAPL-based system is very similar to an XACML or NGAC-based system. We again have policy enforcement points, policy decision points, policy retrieval points where policies are stored, and external sources for data called policy information points, which help the policy decision point to make the right decisions. The major difference here is that instead of following a strict request-response protocol, SAPL implements a publish-subscribe scheme, and all data sources used are data streams. So policy information points are data streams, the configuration of the PDP is a data stream, and the policies by itself are also data streams. A policy enforcement point subscribes to a policy decision point, to decisions matching a subscription, and the policy decision point will continuously update the policy enforcement point whenever the conditions change and result in a new decision to be enforced by the PEP. The publish-subscribe protocol is JSON-based and uses server-sent events with ND-JSON as a media type. Subscription contain a subject, an action and a resource, and an optional environment, which all are arbitrary JSON values, and decisions can be returned containing the decision itself, obligation advices, and an optional replacement resource. In addition, SAPL supports multi-subscriptions and multi-decisions. What you can see here is the interface of a PDP server. You can administrate all the policies and combining algorithms, see the documentation for different policy information points and libraries. The core feature is the support for authoring of policy documents. The provided editor supports syntax highlighting and allows for code auto-completion. The SAPL syntax aims for maximum human readability. So SAPL policies should be easily understandable even by less technically inclined personnel and stakeholders. All policies are validated during editing. SAPL allows for filtering of resources. This enables the removal of data from JSON data structures or for the blackening of substrings. Accessing attributes in SAPL is done by accessing properties of JSON objects. Whenever an attribute is sourced from an external policy information points, an angle bracket notation is used, and the resulting attribute is interpreted as a data stream. The presented server allows for versioning of policy documents and select publication and activation of policy versions. SAPL comes with a number of framework integrations. For example, for the Java Spring Boot framework, where you can use annotations and declarative policy enforcement points to secure your application. Similar features are available for the Django framework in Python, which also supports a custom template tag library. The resulting applications will automatically deploy policy enforcement points and ensure that resources are filtered where needed, obligations are fulfilled, and in general policies are enforced. The next short demo shows how an actual stream-based policy enforcement may be applied in practice. On the left hand, you see an application which is displaying data streams from a medical domain, the heartbeat rate and blood pressure data from a patient, and on the right hand side you can see the PDP administration interface, which is doing the decision making for the given application. In this example, the access to the data streams is controlled by a simple time-based policy controlling during which seconds of a minute access is granted to see the data. Here I simply change the interval of seconds, publish a new policy, and you can see the behavior of the application directly changing without any reload necessary from the user side. Updates of decisions are pushed to the application by the PDP server as the policies have changed. Please let me give you a short overview of testing capabilities of the SAPL policy engine. SAPL can treat policies like any other code in a DevOps scenario with continuous integration and delivery in place. To ensure quality and correctness of policies, unit tests can be deployed and static code analysis during tests can be performed. These tests can be used as a quality gate before deploying policies to production. Also, HTML reports for the coverage of the different tests are generated automatically. Finally, the SAPL Playground is a web application for learning and testing SAPL policies. Data stream sources can be mocked and the responses to subscriptions can be tested. Changes to policies, subscription and data sources take immediate effect. Thank you very much for letting me introduce you to the SAPL policy language and engine. Please get in touch. We are looking for adopters and for contributors to the engine. Thank you very much and goodbye.